Okay, having looked at the various schemes of sampling and found that track and hold probably is the easiest or the most practical of all sampling schemes, let's look at some kind of circuit implementations to do sample and hold sampling. Okay, so sampling circuits are also called sample and hold, and I think the reason for that should be fairly straightforward. The reason is basically because you want our sampling circuits to do two things, right? You want it to, of course, sample the analog value here, but you also what you want to do is you want it to hold that analog value for some time, so that um, the circuits at the output can do their function, which usually, in case of an analog to digital conversion, would mean that they would do the quantization. Okay, so uh, what kind of circuit would be able to do this kind of sample and hold? The circuit that would do it is fairly straightforward. I mean, if you have a switch here, and let's not get into details of how you're going to implement the switch, but if you want to think about it, you can think about the transistors that we learned about in analog electronics in the previous module, and I think that gives you a hint of how you can build switches. So there are other ways of building switches as well in electronics. So let's say we have a switch here connected to a capacitor. Okay. Now, if you give the input and if the switch is closed, that is, this input is connected to the capacitor, the output is basically going to be equal to the input. So in the acquisition mode, the switch is going to be on or the switch is going to be closed. So the output will basically track the input. And if then you open this switch or you switch this switch off, then what happens? Whatever value is at that instant, as that switching instant, is going to be maintained for some time. So that's the hold mode of your track and hold. So you have the acquisition mode when the switch is closed, and you have the hold mode when the switch is open. And that's how you can actually take this input signal and sample it at different instants of time. Um, Now, of course, this kind of a circuit is not going to be practical. The kind of circuit that we looked before, this is not practical. Basically, because the output circuit is going to load this capacitor in the hold mode, and the capacitor voltage is just going to drop down. Okay. Also, this capacitor might load the input here and therefore distort the input. So to prevent distortions on both ends, what we do is we put buffers. So you put an input buffer at the input so that this capacitor is not able to load the input, and at the output we put this buffer so that whatever circuit is there at the output does not discharge our capacitor or load our capacitor. So this circuit would be a very, very basic sample and hold circuit. We'll look at the fact that there are some problems with this circuit, and in the next video we'll take a look at the performance metrics of sample and hold, which try to kind of recognize and measure some of the non-idealities and some of the problems that come with this kind of sample and hold.